Hi students, welcome to this session here at the Sri Chaitanya channel. In this session, we'll mainly be talking a bit about the score exam, what the syllabus is, when the tests are, and also we'll be doing a few questions. Now, these questions are quite relevant for you, not just for the score exam, but also for your JEE. Now, I've just chosen questions mainly from work power energy because that's one of the most important parts that you will have questions on for your score syllabus. I'll also bring for other chapters to make sure you stay subscribed to the channel to get all of that content, all for free on the Sri Chaitanya channel. Okay, so let's get started. First of all, I believe you all are aware of the score exam, which is the scholarship exam conducted by Sri Chaitanya. It's a national level scholarship exam where participants from all over the country will be giving it. So you'll also get a chance to understand your level as compared to every other candidate in the country. It's for all the way from classes grade 3 to all the way till grade 12, conducted by Sri Chaitanya. It has both online and offline options. For the online, registrations are completely free. For offline, there's a minimal charge of around 150 rupees, and you will have to go to the closest center. Sri Chaitanya centers are there in almost every state. In the city that's closest to you, you'll find the Sri Chaitanya center. You can go and give the exams over there as well. Okay. We have lots of things. You have 100% scholarship on Sri Chaitanya courses. That's not just the mains courses. There's advanced courses, Olympiad courses, and all of them you'll get 100% scholarship. You'll be competing with all the top minds in the country because this is a nationwide scholarship exam. So even if you don't want to join or anything, giving the exam is like a practice for your JEE Mains. Then you'll have cash prizes, gadgets, you have laptops, tablets, many other things. And you'll also get the NASA trips. If you are among the top rankers, you'll also get NASA trips that will inspire you to do even further, even better in your JEE exam. Okay. That being said, let's get into the questions for the day. First question here says, two similar springs P and Q have spring constants Kp and Kq such that Kp is greater than Kq, meaning P has a greater spring constant than that of Q. They are stretched by two cases. In the first case, they are stretched by the same amount, which means the extension or the compression in both of them is the same. In the second case, they have been stretched by the same force. Now, if you stretch them by the same force and they have different spring constant, their extensions are going to be different. So in the first case, the extension is the same. In the second case, the forces are the same. They are asking, based on that, the work done by the springs WP and WQ, how are they related in each case? First case A, then case B. How do you deal with a question like this? We know that the work done formula for stretching a spring is given by W is equal to 1/2 kx square. That's known to us. Now, based on this, we can't use exactly this formula for both cases. Why is that? Based on this, you can tell work done is proportional to the spring constant. I can write work done is proportional to the spring constant. But keep in mind that proportionality we can only write as long as x is a constant. If x is variable, then I'll also have to put W is proportional to x square. If I only want to judge the work done based on the spring constant, then over here the extension has to be the same. It has to stay constant. Which means this will work for case A. For case A, this will suffice for us. Which means if Kp is greater than Kq, I know since it's directly proportional, work done in case A, work done by P would be greater than the work done on Q. What about case B? In case B, I can't go by this relation. I can't write work done proportional to K. The reason being, in case B, the extensions might be very different. They might not stay as just x for both. They might become, one will have x1, another will have x2. So what do we need to do? We readjust this formula a little bit. W equal to half, we write it as k square x square divided by k. The benefit of doing that is now this kx is the force. We know a spring force is equal to kx, which means this formula can be written as half times 4 square divided by k. The benefit of writing this is in case B, I know force is a constant. It's same for both, which means for case B, work done is inversely proportional to the k. This is for case B. See how it has completely different dependence, opposite dependence based on what other factor you are keeping constant. Which means in case B, whichever has greater spring constant will have lesser work done, which means work done by Q would be greater than the work done by P. So it is option B over here. Okay, you can also put your answers in the chat, students. Meanwhile, we'll go for the next question. It says in the figure shown, a particle of mass m is released from the position A on a smooth track. When the particle reaches at B, then the normal reaction on it by the track is how much? Meaning, when the particle is at this point, what is the normal reaction force it feels in this direction? The surface is on the upper side, so it will feel the normal reaction force downwards. What is the magnitude of that? How do you find it? So right now, if I were to draw the free body diagram of that body on the top point, the normal reaction force acts down, the weight also acts down. In the upward direction, because it will have a certain speed, the upward direction, there will be the centrifugal force, mv square over r. Thing is, we need the n, we can find based on the mass m is provided, we need to find what this v square is. How do we do that? You see, we launch it from here with an initial speed of 0. And since this is at a height 3h, whereas this is at a height of 2h, because h is the radius, so opposite point is at a height 2h. So from 3h to 2h, when it comes down, there is obviously going to be some potential energy converted into kinetic energy. How much potential energy is converted? mg into h. From 3h to 2h means the height decreases by h, which means I can find that the kinetic energy half mv square is equal to mg into h. Basically, it is 3h minus 2h. What does that give us? That gives us mv square is equal to 2 mgh. Now I keep it as mv square because that's how I can apply it here. Based on this diagram, I know the normal reaction force is mv square by r. By the way, the radius is the same as the h here as given in the diagram. mv square by h minus mg. mv square was 2 mgh. Plug that in. 2 mgh by h minus mg. Take the h's out. You have 2 mg minus mg. That is just mg, and yes, that is your normal reaction force. Option A. Okay, we go for the next one. It says a body of mass 1 kg begins to move under the action of a time dependent force. Force is given to us as a I cap and j cap. It's given in its vector component form, where I cap and j cap are unit vectors, so on and so forth. What power will be developed by the force at a time t? Now, since they are asking power at a time t, meaning they are asking for instantaneous power. Instantaneous power is not work done by time. That's average power. Instantaneous power is always dot product of force and velocity. Thing is, we have the force. We need to find the velocity. How do we find the velocity? I know acceleration as a vector is equal to f vector divided by the mass. And velocity as a vector is just integration of a vector dot dt, which is just integration of f vector by the mass dt, right? So I can write velocity as a vector is equal to, the mass is 1 kg, so I don't really bother about it when I divide the force by it. I have the 2t I cap, so I'll have an integration of 2t dt. Remember, I need to integrate I caps and j caps separately. They are different things. Here I have a 3t square that I'm integrating. dt goes with a j cap. What do we get? 2t gives us t square I cap. And 3t square integration gives us t cube j cap. This is my velocity vector. This is my force vector. Now I can easily go for the power. Power is a dot product of force and velocity. Force was 2t I cap plus 3t square. Sorry, my bad. 2t I cap plus 3t square j cap. And your velocity as a vector was t square I cap plus t cube j cap with a dot product. So what do we get? The I caps multiply. You have a 2t into t square, which makes it a 2t cube. And you have a 3t square multiplied with the t cube here, which makes it a 3t to the power 5. That is the power. I think we have an option. It is option D. Okay. Let's proceed to the next one. It says a body of mass m kgs is ascending on a smooth inclined plane of inclination theta with a constant acceleration of a. The final velocity of the body is v meters per second. The work done by the body during this motion is how much? Okay. There are two ways we can do this. We can go through the force or we can even go through the energy, because we know whatever work you do, that goes into the kinetic and the potential energy. Now it's easy to understand what part goes to kinetic energy, because starting from rest develops a speed v, so kinetic energy is half mv square. But we need to find what is the potential energy. So let's draw out the diagram. Let's assume this is theta. They have never said that the particle starts from the base of it. You can start from the base, wouldn't really matter. And let's say it goes from here to here. Here the speed was 0. Here it develops the speed v. The acceleration is given as a. I'm assuming that this distance is s. Then I can tell that if from 0 velocity develops the speed v, traveling a distance s with an acceleration a, then s is equal to v square divided by 2a. That's the basic kinematic equation, comes from v square minus u square is equal to 2as. That s once we have, remember I want to find for potential energy, I want to find what is the height difference. So basically, I want this distance. If this is s and if this is theta, I also know this will be theta, then h would be equal to s sine of theta, right? Because it's the opposite to the theta, and s is the hypotenuse, which means my h is equal to v square by 2a, and say sine theta is given in the question as 1 by x. I put it here, h is equal to v square by 2ax. Now we can move ahead to the work done. Because the work done is the kinetic energy, half mv square, plus the potential energy gained, which is mgh. What do I get? Keep the half mv square as it is, mg into v square divided by 2ax. Pull the mv square by 2 out, you'll be left with 1 plus g over ax. Do a regular LCM because I can see the answers are given in terms of that. I'll have an mv square by 2ax if I do an LCM, and here I'll have a ax plus g. So I think that matches option D. Okay. Next one we go for says that the potential energy of a 1 kg particle that is free to move along the x-axis is given by Vx is x to the power 4 minus x square by 4. Total mechanical energy is 2 joules. What is the maximum speed? How do I go from potential energy to maximum speed? You might think from potential energy we can go towards the force, because F is equal to minus dv dx. But that will not really help us to find what the maximum speed is. What do I do instead? I know that if at any point the speed is maximum, meaning its kinetic energy is maximum. And with the total energy conserved at 2 joules, which is the total energy is divided between kinetic and potential, when the kinetic energy is maximum, the potential energy has to be minimum. So if I can find what is the minimum value of this, then I can find what is the maximum value of kinetic energy, and as a result I can find the maximum speed. So let's try to find what is the minimum value of this potential energy. The way we do is the maxima minima method. We use a dv dx, which gives us 4x cubed by 4 minus 2x by 2. That's equal to 0 because we are doing a maxima minima method. Take the 4's out, take the 2's out. I'm left with x into x square minus 1. That's equal to 0, which means x could be 0, plus 1 and minus 1. These are the 3 possibilities. Now again, I need to find which of these 3 values are for maxima, which are for minima. How do we do that? We double derivate. We do a double derivative. d2v dx2. If I differentiate a second time, and this is x cube minus x, I have 3x square minus 1. Take it, if I put 0 here, I get a negative value, I get minus 1, which means 0 is a point of maxima. That's not what we need. We need the minima of potential energy. If I put plus 1 or minus 1, either of them will work. You see, both of them give you 3 minus 1, which is 2, which is a positive quantity, which means for us, these two are the points of minima. Now I can choose either one. It won't really make a difference because these are there as squares. So I can find my minimum potential energy is equal to, if I put 1 there, 1 to the power 4 by 4 minus 1 square by 2, that will give me minus 1 by 4. This is my minimum potential energy. Since I know that the total energy or the mechanical energy is potential energy plus kinetic energy, that means when the potential energy is minimum, the kinetic energy has to be maximum. And I can find then that the maximum kinetic energy is the mechanical energy minus the minimum potential energy. I'll keep it just P instead of writing PE every time. Minimum. What is the potential energy or mechanical energy? That's 2 joules. Minus what is the potential energy here? Minus 1 by 4. Then sign is important. We get 9 over 4. Now the kinetic energy would be half mv square, mass being 1 kg. Half into mass is 1 kg into the velocity, there is a maximum velocity. That is equal to 9 by 4. Take this out with a 2. So I easily get V max. If I put a root over on this, root 9 will give me a 3. Down below, I'll get a 2. So the maximum speed is 3 over root 2. Okay? Next, we move on to this one. It says a force acts on a 30-gram particle in such a way that the position of the particle as a function of time is given by x is equal to 3t minus 4t square plus t cube, where x is in meters, t is in seconds, and the work done during the first 4 seconds is how much? Now you could obviously go the entire way. As far as I remember, this would be 3 grams if I'm not mistaken. So over here, one thing you can go is you can try to find the velocity, from velocity get acceleration, from acceleration get the force by multiplying with mass. And then you can do f dot dx. The problem with that method is since they are all in terms of time, you'll have a really hard time pushing it to the integration. You'll have it in dx, the dx you'll have to convert to dt, it will become really messy. So how do you deal with it? We deal by using the work energy theorem. First, I try to go towards the velocity. Velocity is dx dt. If I differentiate it, what will I get? I'll get 3 minus 8t plus 3t square. That is my velocity. What is the velocity at the very beginning at t equal to 0? If I plug it in t equal to 0, you see that's just 3 meters per second. What is the velocity at t equal to 4 seconds? Right? At t equal to 4 seconds, it is 3 minus 8 into 4 plus 3 into 4 square is 16. What do I get? I get 3 minus 32 plus 48, that's a 16 plus 3, that would be 19. That is my V4. Now I know work done is equal to the change in kinetic energy, which is 1/2 m V4 square minus V0 square, because 1/2 m V4 square is the kinetic energy at t equal to 4, 1/2 m V0 square is the kinetic energy at t equal to 0. So we take them in. Mass is 3 gram, so 3 into, I'll keep the 10 to the power minus 3 later on because I see lots of millijoules here, I don't really bother about it. V4 is 19, I have a 19 square minus this is 3 square. What do I get? This is in millijoules, okay? 1/2, 3 into, I have a 361 minus a 9. That is going to be 361 minus 352 times 3 by 2. I think I can take this out. This will go with a 176. I can find 176 into 3. Let's see what that would be. 6 would be equal to 18, 120, 122. There would be a 2 on top. That would be 5. 528. So the only possible one close to it is option D at 530 millijoules. Okay. Let's try the next one. It says a steel ball of mass 5 gram is thrown downwards with a velocity of 10 meters per second from a height of 19.5 meter. It penetrates the sand by 50 centimeter. The change in mechanical energy would be what? So over here, you are essentially throwing it from a height. From this point you're throwing, and say from the ground it's 19.5 meters. When you're throwing it down, it obviously has some speed. Okay. Or I think it's released. It's thrown with a speed. It's thrown with a speed of 10 meters per second. Now, right now, it has both kinetic and potential energy. As it moves down, the potential energy gets converted to kinetic. At this point, you might feel that the entire potential is converted to kinetic. But the thing is, it actually sinks a little further down, 50.5 meter. So what you have to assume is that this is your new ground level. This is your new ground level. Technically, your change in height, when we do change in potential energy, that is mg into change in height. Your change in height is not 19.5. It is full 20, 19.5 plus a 0.5. That's what you have to keep in mind. So over here, you see, when it sinks down, not only is its potential energy gone, but its kinetic energy is also gone, because it has eventually sunk into the sand and stopped. So all you're trying to find is what is the total change in kinetic energy, which will just be equal to change in mechanical energy. Change in kinetic energy is whatever speed it had here, that has become 0. So it's just half m into, I'll keep it v square, plus mg into the h. Mass is provided to us as 5 gram. I'll keep the 10 to the power 3s and all that later. V square is 10 square, that's 100, plus mass is 5 grams, G is 10, and the height is 20 meters now. There's a 10 to the power minus 3 because this was given in terms of grams. What do I get here? This goes with a 50. I have a 250 here, and here I have a 1000. 1250 times 10 to the power minus 3, that gives me 1.25 joules, option B. So please keep in mind that if it sinks further down, you can think of that as the new ground level and find on the basis of that. Okay? Let's proceed to the next one. It says a 10 horsepower motor pumps out water from a well of depth 20 meter and fills a water tank of volume 22380 liters at a height of 10 meters from the ground. The running time of the motor to fill the empty water tank is how much? So over here, since it's lifting this much, okay, since it's lifting that much water up to a height, you can see that basically the pump is giving the potential energy. And here we are looking for the average power it's given as 10 horsepower. So we can use that power is equal to energy given by time. I'm looking for the time, which is just the energy divided by the power. Problem is, the energy is what? The energy is just the potential energy, which is mgh, divided by the power. Now G is given to us, height is given, but mass is not given. Instead, we have been provided that 22380 liters of water are sent at that level. Why is that important? And how can we use that to find the mass? You see, water has a density of 1 gram per centimeter cube, or 1000 grams per liter, because 1000 centimeter cube is 1 liter, which basically means water has a density of 1 kg per liter, which means 22380 liters stands for 22380 kgs of water. So now you have the mass, 22380 kgs, G is 10, height is 20 meters, divided by the power is 10 horsepower. Remember, each horsepower is 746 watts. Take one of these 10s out. 2238 is 3 times of 746. So what do you have? 3 into 10 into 20, that's 600. What we got here is in seconds, not in minutes. So in 600 seconds stands for 10 minutes. Divided by 60 basically. Okay. Next one we go for. It says an engine pumps water through a hose pipe. Water passes through the pipe and leaves with a velocity of 2 meters per second. The mass per unit length of water in the pipe is 100 kg per meter. What is the power of the engine? Now, how do you go for the power? You can understand that the power is basically giving the kinetic energy to the body. If there's a mass and it's giving it a velocity of 2 meters per second, it is providing the kinetic energy. So if you want to go by the formula, you can go. It's the kinetic energy provided divided by the time. The problem is, you have not been given the mass, you have been given the mass per unit length. You also have not been given any mention of the time. So how do you deal with this? You can multiply a length term in the denominator and the numerator. This length represents that in a certain time t, how much does water move? So basically that length would just be v into t. If water is moving at a speed of 2 meters per second, then in that time t, how much distance does it move? Because that is also the length of water that has been given that speed of 2 meters per second. Now the benefit of doing that is that you have this m by L, which is exactly what had been given here. It was in kg per meter. But because we know L is V into T, I know L by T is equal to V. So this L by T here is the same as the velocity, which means I can write this as half m by L into V cube, because there was a V square and there was an L by T, the L by T is V. There was the V cube. So let's plug it all in. Half mass per unit length is given as 100. And V cube, velocity is given 2 meters per second. We cube that, I get an 8. 4, that is 400 watts. My bad, we are finding power. So it is 400 watts over here. Alright. So I think that was the last question for the day. These will all help you not just in your score exams, but also in your JEE preparation. If you want question practice on a specific chapter, you can obviously request that in the comment section. We'll try to bring those sessions. Meanwhile, I'll tell you a little bit more in case people who have joined a little later. The session is mainly to prepare you for the score exam as well, which is a both scholarship exam by Sri Chaitanya, all the way from grade 3rd to grade 11. It's there. It's both online and offline. So offline centers are there distributed throughout the country. It's a nationwide exam, which means almost 1 lakh participants would be competing. You'll get to know where you stand among all of those candidates. The exam dates are on 28th September and 12th October, and the registrations are there at srichaitanyascourt.com. Okay. This, by the way, is the syllabus for your for all the grade 11 students. You can get the 100% scholarship for grade 12 or for Olympiad courses. Physics is there only till rotational motion. Mainly the mechanics part. Chemistry has some basic concepts, structure, classification of atoms, classification of elements, chemical bonding until thermodynamics. Whereas maths is sets, relations and functions, trigonometric functions, sequence series, straight lines and limits and derivatives. That is your maths syllabus. Okay, the score exam, there's still some time. It's on 28th September, so there's time. But even till then, this is what the syllabus is going to be. And we'll obviously help you prepare more through more sessions like this. Okay, these are your test dates, registration dates, and all are provided here. But please don't wait till the last date of registration, because lots of students give the exam towards the end. Just like what happens with JEE Mains, it can get a little clogged. So I'll request that you register right now, especially because registration is completely free. Okay, so we'll keep it till here then. If you enjoyed the session, do like this video, do stay subscribed, because we'll be having more sessions like that. And follow us on all our social media channels. There are more updates about the score test or classes like this, free classes like this would be provided there. That's it. Thank you all so much for tuning in for this session. I will catch you all again in the next one.